then you have, if you know, then you will able to easily understand those drawings.
So what is the meaning of countersink and counterbore?
That I will explain. That is a manufacturing thing. So that, like, suppose you have a if you are drilling in a simple way you can say, like, suppose if you have a one object, rectangular object, and you are trying to uh, one transverse and one rectangle in axial direction. So that way I have to draw the things, then you will able to understand. So we'll show you those things. Here just I am trying to give you some overview to get some, because these notations you will see in the chapter, like rivet joint, then screw, fastener, etc. Okay, so in that those chapter will see in detail what are the meaning of this deep hole, or you can say this countersink, or drill through hole, counterbore. So those terms are manufacturing terms. So those things we'll see. I think you already studied for manufacturing part one, right? Have you studied manufacturing part one? Manufacturing engineering
Yes, sir.
part one? Then you should know, because that is the manufacturing operation. Okay. So those things you should revise. If suppose you have some difficulty in understanding of a thing, then those things you should revise. Then there is some terms and related abbreviation in drawing. You will see this type of abbreviation. So you should understand, like AYC, that means across the corner. Then AYF, that is across flats. So those things you should understand. So if you know, see, these things you will get through the practice. Suppose if you are doing the same thing, your job is to check the drawing or design, then if everybody will check, then you will able to remember these things. Okay, the AYC, the abbreviation is for across corners. Okay, like for cheese heads, CHHD, pitch circle diameter, PCD, pitch circle PC. So this you will get from practice. But at least you should go through once. I'm not telling you should remember, right? I'm not telling you to remember, because whenever you design something or you draw something, these things like design data handbook or some reference book you will able to see. With the reference book you can use some data also. Suppose if you are designing something, then these are the abbreviations for materials, like aluminum, brass, bronze, Al, brass, bronze. This brass and bronze is written like this way only. This is not in sort of format. Cast iron, CI, cast like this. Have to see. Now, before going in orthographic projection view, we'll try to see the basic of AutoCAD first, and then we'll see the AutoCAD software, and after that we can start the orthographic projection, because your practice things will start from the orthographic projection view. Yeah. So this CAD is like the AutoCAD basically. Basically, this AutoCAD or automatic. Basically, CAD is like a computer design. With the help of computer, you try to create a model, right? Wait one minute. My computer is little bit slow. That's why. Yeah. Give me 5 minutes. Not moving. Are you able to see this my screen? Second slide. So first one
Yes,
is
sir.
introduction to AutoCAD, and then this. Yeah.
Yes,
So
sir.
this computer aided drafting program, that is AutoCAD. Uh, that is most popular CAD software for a drafting purpose. There are many commercial software available for a CAD. That is there is a CATIA, SolidWorks, UG, Unigraphics, then NX, Ideas. There are many Pro-E, now Creo, I think. So there are many CAD software commercially available. Even there are some open source software also available, uh, like LibraCAD and all. So that almost the function is same. Here also you used to draw the detailed drawing. In the open source software also you will able to. But there are means in terms of functionalities and in terms of volume, the AutoCAD is bigger than the open source available open source software. So this AutoCAD you can use in a different um, areas, like suppose if you are dealing with the drawing construction, architecture, then mechanical design, then suppose you have to you are even if you are interested in making some art or some biomedical imaging. So those things also, like suppose if you are interested in doing image reconstruction, you have a CT scan images and you want to make a 3D model, so you can use the uh, each CT scan images to make surface. First, you will make a surface using the polyline, and then you will try to create a volume. So that way, you can use to 2 3 different software to make the solid model. But initially you can do in like segmentation and all those things you can do in AutoCAD. So drawing is the language of engineers. Then AutoCAD or computer-aided design machine has been a great help to engineers and also for several architectures that are finding it impossible to deal with the drawing and plans for the project engineering works and the bring on the verge of perfection. So this AutoCAD is commonly known as computer-aided design. Is a software application for writing and design 2D and 3D. Even you can deal with the 3D, but that is not 3D is not user friendly. Nowadays there are many even in Autodesk also there are many like upgraded version software available like Autodesk Inventor and all Fusion. So there are many 3D modeling software also available from this main company, that is Autodesk. But earlier the 3D was not popular from this AutoCAD. Now same thing like both 2D and 3D computer aided design you can do, and it is available since 1982 as a desktop application, and even now you can use this AutoCAD in mobile web or cloud based app also. And currently it is marketed as AutoCAD 360, and this is developed by Autodesk Inc. and it's first released in December 1982. And the founder, Autodesk founder, is John Walker. And now, right now, I think 18th or 19th generation, this software is currently marketed in its 18th generation. So in this software, you can use different commands to draw. Like suppose geometrical, if we talk about geometrical commands, then we can use line command, circle command, arc command. For a specific command, you need to give some input. Suppose if you have to draw a line, then you need to give the two end coordinates, right? Here there is object snap, then zooming and panning, drawing 2D shapes, drawing 3D shapes, editing, then coordinate system. Even you can prepare a drawing in different sizes, means you can even customized. So there are different designation for a paper size. So here you can see A0, A1, A2. Already we seen this size. Command line you have to write. These are the toolbars, drop down menu. Through drop down menu, you can see the different commands also. O snap is like object snap, and you can under this you can see, or you can this check this endpoint midpoint of a, if suppose if you are drawing a line, you want to check midpoint, you want to check endpoint, so that those things you can, if you will on this feature object snap, then you will able to observe every time endpoint midpoint, then perpendicular center intersection. And whenever you are picking a point on a working area, then you will able to see those things. Even using command also you can activate this snap. Zooming also you can do. There are different types of zooming, like even you can type Z or you can write zoom full in your command window, and you will able to choose. Like in the zoom you will see there are different options available, like all center, dynamic, extend, previous, scale, window. Then you can choose accordingly, it will something will happen there in the working area. Suppose if you are drawing, then I think this is We'll try to see through the software. First thing is, you should, if you're opening this Autodesk AutoCAD, then you will see this type of graphical user interface. I think all of you are aware of that. This. So here you can see there are different toolbars exist, and you can explore this. Here you can see this is a line command. If you keep your mouse there on the line command, then you will able to see the what this commands do does. So here you can see the line. That line means you can create a straight line segment. Even suppose if you are not understanding, then you can read. Here you can see this line is like line creates a straight line segments. So by reading this also you can understand. So similarly, here you can see this is a polyline. So what is polyline? A 2D polyline is a connected sequence of a segment. So if you want to draw like a rectangle, you can start with this polyline, and you can, that segment will be connected to each other. So in the sequence, okay. So that way you can understand. Then here you can see there is a circle command. Circle you can draw with a different using different commands like center radius, center diameter, 2 point, 3 point, tan radius, tan, all tangent. So if you have a 3 tangent, you can draw a circle. If you have a 2 tangent and radius, you can draw a circle. Using 3 point, you can draw a circle. Using 2 point also, you can draw a circle. And these two are common, means center radius and center diameter already seen. So how these lines are generated here? Can you guess? I am just using this command and I am able to generate a line, right? I'm not going in absolute coordinate system and relative coordinate. Later I will go. So I'm trying to explain the how this software generate line. You have any idea? Anyone can come in and answer.
सर वेक्टर ग्राफिक्स का यूज करके एसवीजी स्केलेबल वेक्टर ग्राफिक्स
So only with vector graphics you will able to get the line. That will help in displaying and all those things, no?
Yes,
you need to write algorithm for line generation. You know the equation of line, right? You know the equation of line. Now you will use that equation to write algorithm. And that will help you in generate this straight line. Some developer have written some code, no? Then only these things are coming. Whatever you are doing with a graphical user interface, same thing you can even use some MATLAB programming or some other programming and generate, right? Are you getting my point? Because whatever the geometrical things you are seeing here, that is with related to the equation, no? Because see, in the there are two different types of curve. Curve comes under the means lines, and under the curve line also comes, right? So basically there is a analytic curve and synthetic curve. Analytic curve means natural curve. Synthetic curve means you are combining two natural curve and creating another. So that is synthetic curves. So these things we will study in CAD, computer aided design theory subject later on, maybe in higher classes. But here just you have to understand, because see, because you are using this AutoCAD, so you should know how this, at least by verbally you should know this, how these lines or circle have been generated. So you have to use the equation of line to generate circle. You have to write the algorithm for equation of line, and that also you can generate by the writing simple by equal to mx plus c, and even you can write a parametric means you can write the equation of line in parametric form. There is a two different form, non-parametric and parametric form. Okay, so both we can do. But nowadays, whatever the commercial software you see, like this CATIA or SolidWorks or any other, that is written in parametric, so that you can easily even they do the fine transformation also. So those things we will study later. We will not go in those much details. Just you have to understand that the equation of line has been used here to generate it. So you need 2 points, right? 1 point is this one and 1 point this one to generate a line. Now this polyline is continuous, as you have already seen the definition here. The sequence, in sequence you can generate. You can use this polyline, means usage I am telling. One of the uses you can, if you are making a continuous sequence geometry, then you can use. Or otherwise, suppose if you are dealing with a, like if you are trying to construct a solid model for a biomedical application, like suppose you have some bone images, CT scan images, and you try to build as a volume, then you have a separate segmentation. Each segmentation you can take in this AutoCAD, and then you have to manually, by using this polyline, we have to draw the boundary like this way, and then you can create a region, and then you can convert into surfaces, and after that all the surfaces you will join, and then you will get a irregular solid model of a bone or some other, whatever the things you have selected for your study. So that is one of the application for this polyline. Otherwise you can use simple like continuous sequential geometry. If you have something, you can make that. Now here you can see there are different methods to create a circle. So you can create by center radius. That is very easy. Just you will click this center, or here you can write. And if you want to give just center point, so just click anywhere, or you can give the coordinate points. And then you have to specify the radius of the circuit. So you can specify, see, 5. So here you are able to create a circuit. Similarly, if you want interested in creating by this one center diameter, then also same thing. You have to specify the center point, and then you have to specify the diameter. So you will get this, right? Now the other one, there is a 2 point. You have a 2 point, you can create a circle. So these commands you should know, so that when you will use the different detailed drawing or sectional view, then you should use, because you have to explore. There is no other option. You have to explore the different commands, and then you have to, after seeing the 3D model or any machine component, you have to draw the different orthographic projection view. So if you know all the command, you can easily do, right? So this is just like your suppose if you are doing a manual drawing, then you have a different accessories. So that is the same thing. Here you have a different accessories, different commands, and when it will require, then you will try to use these things, okay, these commands. Now 2 points. 2 point is this. Click this, or you can write also. Specify first in point of a circle diameter. So okay, I will try to click somewhere, and then we have to specify second in point. So second in point here. This is the way to do the this use this command. Then 3 point. You have a 3 point. You can draw a circle. So suppose specify first point, second point, third point. You are able to draw the circle. Okay. Similarly, tan radius. What is this? Create a circle with a specified radius tangent to a two object. So first we have to draw the two object. One object is there, two second is this one, and tan radius. So suppose I am selecting this point, and then again we have to specify second tangent of the circle, and then I have to give the radius. So that is not, I mean, that is not. Yeah. So automatically here tangent radius. We have, for this you need two object. So we have here we have two object, and we selected two tangent points. So here and here, I will just delete this, and then I will. So you know these things. I need to explain in a more. Hello, all of you know these things, or I need to explain? Nobody's. Hello, hello.
Yes, sir.
So
Yes,
please
sir.
explain, sir.
Explain. Okay.
Explain, sir.
Okay. No, you have to speak now. Okay. Now this I was tangent radius. So just select this command. Then see, specify point on object for a first tangent of a circle. So if suppose I want here, then I can select add here, and then I have to give the radius. So automatically it calculated the radius, and that was coming by default. So this way you can do. Then
Sir, can
third
we
one,
do at the line?
what?
Sir, can we do with a circle and a line?
Circle is all. If you are talking about line, yeah, I think because line is also a tangent, na? If you are trying to do with a line, you will do that will work. Now here only you need two object, okay, to use that. You can't use with one single object. Now the third one is tangent. So you need three object for this. Something you can draw here. See, you have to draw geometrically possible diagram. I am here just doing randomly, right? So you have to suppose if you are designing something, then your whatever you are designing, that is that have some calculation or dimension or geometry, right? Geometrical side or shapes. So Whatever you will draw, that should be geometrically possible. Try to see. It will adjust or not. We'll see. Tangent, tangent, tangents. I think all tangent I have to select. See, so all three tangent. So that way you have to explore also. You need to explore this software so that you can know, you can use means maximum command, and you can then you will even reduce the your modeling time or detailed drawing time. Whenever you will do the exercise, then if you know this command, if you know how to use this command, then you will able to reduce the drawing time, right? Now here you can see, you can draw a arc also. There are different method to draw a arc, that is depending on the usage. Means if you have some specific model or a part machine component, and you can use different types, different method to draw a arc, which one is whichever is suitable. So first one is 3 point, then start, center, in. Whatever the sequence we are seeing here, that the same sequence we have to use. Okay, suppose this 3 point, so you have to use 3 point. You will able to produce a arc. Then a start, center, end. This is a start point, this is center point, and this is the whatever the end point you will give, that is the. So I am giving end point here, so that much it's taking. Then start, center, angle. Start, center, and angle. Angle you can, if suppose if you want 90 degree, 90 degree. So that way you have to do. So there are different method, like even say start, center, length, start, end angle, start, in direction. Suppose you know the direction and you know the starting point, then you there is a possibility to draw a arc. Start, end, radius. You can use a center, start, end, center, start, angle, center, start. So you should explore these commands whenever you are trying to practice. Then you try to click and then see what it's saying in the below command line. Whatever that is saying, try to use that. Only if you will practice, then only will able to know. Okay. Now there are different geometrical transformation also. But before going in that, we can see here the trim. So suppose I have this type of something. I have this line, and I try to draw one line. I want to trim this extended things. I want to just include the inside line only here. So I have to trim. So for trimming, you can select the trim command, and then select the object. My object is this one. Enter. Now I have to trim this one and this. So we can click here and click here. Got trimmed. Come out of command. So this way you can use the trim. There is a extend also. Same way. Now fillet. Fillet is there are I think three types. Fillet, chamfer, and blend. So fillet one is round. Whenever you see the corner, maybe you have observed. Suppose if we take example of a mobile phone only, smartphone, you can see the corners is round. So that is filleted. In chamfer, you will see in the many sometime for a table or a desk, you will see that is a little bit slant at the corner. So that is called a chamfer. And blend curve is like you are trying to combine the two different types of curves. So that is called as blend curves. So suppose I have something like this, some object like or directly we can make it. And then we try to fillet at these corner points. Fillet. Now, after selecting this fillet command, it is saying that select first object. Okay, my first object is this one or this one, whatever. This one. Second, this one. Now see, you are not able to see. So it's saying fillet radius is invalid. I think something was coming here. So again, we'll try to see. Fillet, 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 fillet. Now I will try to define the radius, fillet radius. So I will try to write here rad r. So now it's asking specify fillet radius. So maybe 4 I am giving. I don't know the unit for this because I have to set first the unit. Now select the first object and second object is not selecting. Why something is second object or shift select to play. This is because of region, I think. Right, fillet this point and this point. See, this got filleted. So radius is little bit large. We can reduce that. Fillet again. We can see this fillet radius, and we can give 1. Yeah. See, fillet. That is out of. So we have to give the command and then we have to use. So this way you can use this fillet. Same way you can use chamfer. In chamfer we can see this also. Control Z. Chamfer is like select first one, then second. But here you have to also set the distance. So it's we can again now distance. So it's asking specify first chamfer distance. First chamfer distance from here to here and here to here. We have to specify. So suppose I am giving 1. Second chamfer also I am giving 1. And then I am doing. See. So from this to this and from this to this. That distance is 1. So that is chamfer. Okay. Similarly, there is one array command. Suppose you have one plate and you need to make a some rectangle, not rectangular, circular hole in a similar pattern, rectangular pattern. Or suppose you have a some circular plate and you want to make a circular pattern in that. You want to make a hole at certain angle. So you can use this pattern array command. In solid, in some other software, we'll see there are different terms like pattern. So here in the AutoCAD, there is a term array, rectangular array, path array, and polar array. The name is different, but the definition is same. The working is same. You can create. Suppose we can see here. Suppose I have to create a hole. Just making here. Now we can use this rectangular array. Select the object, select it, enter. Now I have to give how many circle you need in X direction and Y direction, means column and row. So here they see column, that is 4. This is in this array, column direction is this one and row direction is this one. So you can define, suppose if you only want 3, then 3, and see, after getting activated 3 by 3 only. And then suppose you want distance more, 4, 3. See, the distance between the center to center distance, you can see larger than earlier. So those things you can define, we can do. Even suppose if you are dealing with this polar array, same way, select object, whole object will come. Okay, circle. Because if I will select this circle, then this 3 by 3 whole means all 9 will come as a one object, and that will be come with some certain angle. So I will take one simple small circle and I will try to show the polar array. Select this one, enter. Now center point you have to give. Suppose the center point is this one, then you can see here you have to define the items, how many circle you want here, then angle. If there is a 6, then angle between this and this is 60, right? So if you want to increase or decrease, you can do that. Here you can do all those things. So this is the way you can generate a rectangular and polar. Similarly, there is one more option here, path array. You have a one curved line, and along that curved line you want to create a certain pattern, like then you can create using this path array in that direction. Okay. Now this, or before that, I should I think define this layer. Then we'll see. Layer is like, already you have done the engineering graphics, so you know the different types of line, right? What are the different types of line? So here there are some, in the database there are some different line types that is already exist with the ISO standard, and here you can see this. So suppose I have to use the center line, so I will try to use this center line. So center line, this, or there are different types of center line also. So that is totally depending upon you, how you are selecting, which one you want. So center line, okay, select this, activate this. Now it is activated. Or if you want color, you can change the color so that you can differentiate. Okay. If you want to increase or decrease the line thickness, that also you can do. See, I'm just increasing. If you want to freeze, if you want to lock, everything you can do here. Different, because when you try to draw a detailed drawing, then suppose you want to differentiate between these used lines, then you can use colored, or and even this thickness. Thickness is totally depending upon the rules of graphics, the rules of drawing. So that is not, you can't do like you can increase the thickness which will look word. So you have to use your engineering drawing sense, and then accordingly you have to select. So now if suppose this is you can name also, like rename option maybe, I think. Yeah, rename layer. So here you can rename something like DFG whatever, and can use. Now here I already defined this DGF, that and then I can now suppose I have to change the color of this. You can select this and change. If you want to change the color of this line, you can select here. So whatever you will define here, it will come in drop down menu. All these things will come. So in the layer, you will able to use the different types of line width or line thickness. You can increase or decrease. Then even suppose if you want to lock that line, then that also you can do. So try to explore this layer also. Okay. Then comes the dimension. You can write text also. So here you can see there is a multi-line text and single line. Suppose I have to write single line, so just click here, and you have to specify the height. So maybe 100. I don't know the dimension of this. Rotation, if you want 0 angle, so 0, and then you can write whatever you suppose. This is a machine drawing class, machine drawing. So you can write in multi-line, you will get multi-line here. So that way you should try explore these things. Then comes the dimensioning also you can do. There are different types of dimension. Still we are in command. Now here you can see there is a linear dimension, aligned dimension, angular dimension, arc length, radius, diameter, ordinate, odds out. So whatever the required, you have to, I think already you know the dimensioning rule, you can use. So if suppose I have to use this linear one, I will select from here to here. If I have to see, the text size is very large. See, the dimension is coming something 5.76. This is not, this is basically in certain I think in Germany they use this decimal point as a comma. So you can see this is a 5.76. Okay. So that we can decrease. We can use the command dim style and modify. Text height is 20, that's why. So that you can decrease maybe 5. Okay. Set current, close. See, this is all right now. This the text size is very big. You can more decrease by using this dim style command. Modify. Here you can set many things like this arrow size. Also you can use even the colors of these lines, fill colors. Everything you can explore. The line color, symbols and arrows size also you can decrease or increase. Jog height, linear jog dimension, everything. Fit. Then this tolerance also. This we'll see later. Tolerances and all, fitting and tolerances we'll see later. So these things you can set here. But always you have to, after modification, you have to use this set current. Then only it will be applicable. For setting the units, you can write the here units. You can use the commands units. You can see here the drawing units window came, and now you can change here whatever you have interest in, millimeter, miles, centimeter, meters, kilometer, whatever, micro inches. So based on the requirement, you have to choose the unit. Okay, here you can use the precision, decimal point, and all those things. Okay, then the first command you should learn. There are many things still left here. We'll try to explain later. Because see here, I have to tell about the geometrical transformations. Suppose if you are trying, if suppose you have this rectangle, this rectangular things, rectangular geometry, and that you want to rotate or move some move at a certain distance, then what is happening? What is happening behind this screen, behind this graphical user interface? What are the mathematical operations involved? So we'll try to give some idea maybe in the next class. So before, because still I have 1-2 minutes, so I will try to explain about the working area. Working area is like here you can fix limits, you can use limits commands, limits. Here you can see after entering this limits command, you can see here coming specify lower left corner. So you have to specify this left corner. So that is 0, 0, 0, comma 0. Then specify upper right corner. So here you can, as per your drawing model requirement, you can set the upper right corner. Suppose I have a machine component which is having maximum dimension of 500 millimeters. So we'll try to give some 550 so that it can be well within the working, because I have a working area limitation for 500. So 550 we can give, or 600 also we can give. As per your wish you can give. Then zoom command you can use. Then there are, see, there are different types of zoom. You can use I want to zoom all the area, so A can type, and then you can see. Now you can see this coordinate point here, we are, that is changing. So it is not like whatever the working area you have gave. So it will be more than that, because I'm trying to zoom all. Okay, so a little bit more you will see. Here you can see there are 811 at this upper corner. You can see there is 860 and 537. So this way we have to set our working area in this AutoCAD. Okay. Now I think next time I will try to explain this geometrical transformation, and then we'll go in orthographic projection. Okay. So maybe after next class you have to practice more. Right now just we are trying to explore these things. Okay. Okay. So if you have any question, you can ask. Otherwise, I will stop. Hello? No question?
Yes, yes.
No,
Okay.
sir.
No.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Meet
sir.
you next week.
Thank you, sir.
Same day.
Thank you, sir.
Thank you, sir.